Closure property of addition. Look at the following pairs of integers and solve them. For example, 17 plus 23 is equal to 40. Minus 10 plus 3 is equal to minus 7. Minus 75 plus 18 is equal to minus 57. 19 plus minus 25 is equal to minus 6. Is the sum of two integers always an integer? Yes, this is true for all integers. That is, if a and b are any two integers and a plus b is equal to c, then c will always be an integer. Thus, we can say that all integers are closed under addition. Closure property of subtraction. What will we get if we subtract these two integers? For example, 32 minus bracket minus 17 is equal to 49. Minus 29 minus 0 is equal to minus 29. Yes, after subtraction of each pairs of integers, we get again an integer. Thus, according to the closure property of subtraction, if p and q are two integers and p minus q is equal to r, then r will always be an integer. Thus, we can say that integers are closed under subtraction also. Commutative property. Consider the two integers 6 and 5. What will be the value of 6 plus 5? 6 plus 5 is equal to 11. What will happen if we interchange the positions of 6 and 5? Will the value remain the same? Yes. For example, 5 plus 6 is equal to 11. Thus, 6 plus 5 is equal to 5 plus 6. This property is true for all integers. It is known as the commutative property of integers over addition, which states that the sum of two integers does not change even if we change the order in which they are added. Thus, integers are commutative under addition. If a and b are any two integers, then a plus b is equal to b plus a. Does the commutative property hold true for subtraction also? Let us see this. Consider the integers 9 and 4. Now, 9 minus 4 is equal to 5, but 4 minus 9 is equal to minus 5. Therefore, 9 minus 4 is not equal to 4 minus 9. Now consider the integers 8 and minus 5. We have 8 minus minus 5 is equal to 13. But minus 5 minus 8 is equal to minus 13. Therefore, 8 minus minus 5 is not equal to minus 5 minus 8. Thus, we can say that the integers are not commutative under subtraction. That is, if a and b are any two integers, then a minus b not equal to b minus a. Associative property. What will be the value of the expressions minus 6 plus minus 3 plus minus 1 and minus 6 plus minus 3 plus minus 1? By solving the equation in the line representation, in both cases we get minus 10. It is known as the associative property of integers over addition, which states that if a, b and c are any three integers, then a plus b plus c is equal to a plus b plus c. It's additive identity. When we add 0 to any whole number, we get the same whole number. 0 is an additive identity for whole numbers. Is it an additive identity again for integers also? Now we solve some examples. First example is minus 8 plus 0 is equal to minus 8. Second example is 0 plus minus 8 is equal to minus 8. Third would be minus 23 plus 0 is equal to minus 23. Fourth, 0 plus minus 37 is equal to minus 37. Fifth example, 0 plus minus 59 is equal to minus 59. Sixth example, 0 plus minus 43 is equal to minus 43. In general, for any integer a plus 0 is equal to a is equal to 0 plus a. Yes, we get that 0 is an additive identity for integers. Properties of addition and subtraction of integers. Suppose you have 5 bags that contain 8 apples each. Can you tell the total number of apples in all the bags? To calculate this, we have to add 8 5 times. That is 40. Now, we know that multiplication of whole numbers is repeated addition. Therefore, instead of adding 8 5 times, we can simply multiply 8 into 5. That is 5 into 8, which is equal to 40. Hence, the bags contain a total number of 40 apples. Multiplication of 2 or more positive integers. Multiply of 2 or more positive integers as whole numbers. Their product always carries a positive sign. Thus, for any 2 positive integers a and b, a into b is equal to a, b. For example, 5 into 5 is equal to 25, 7 into 8 into 10 is equal to 560, 9 into 12 into 4 is equal to 432, etc. Multiplication of a positive and a negative integer, that is 3 into minus 5, which is represented in number line by an arrow as 0 to minus 5 to minus 10 to minus 15. But we can also write minus 5 plus minus 5 plus minus 5 is equal to 3 into minus 5. 3 into minus 5 is equal to minus 15, where 3 represents positive integers and minus 5 represents negative integers. Thus, we multiply the integers, put a minus sign before the product. Thus, their product carries a negative sign. Multiplication of 2 negative integers. When we multiply 2 negative integers, we discard their signs and simply multiply the integers. Their product carries a positive sign. Thus, for any 2 positive integers a and b, minus a into minus b is equal to a into b. For example, minus 3 into minus 7 is equal to 21. Minus 15 into minus 6 is equal to 90. Minus 9 into minus 14 is equal to 126. We observe positive integer for all cases. Multiplication of more than 2 negative integers. If the number of negative integers multiplied is even, that is 2, 4, 6, 8 and so on, then the product will carry a positive sign. For example, minus 5 into minus 8 into minus 3 into minus 4 is equal to plus 5 into 8 into 3 into 4, which is equal to 480. If the number of negative integers multiplied is odd, that is 3, 5, 7 and so on, then the product will carry a negative sign. Similarly, minus 6 into minus 8 into minus 10 is equal to minus 6 into 8 into 10, which is equal to minus 480. Of multiplication of integers. Closure under multiplication. Consider the integers 2, 8, minus 4 and minus 3. Multiply these integers 2 at a time. What will you get? Let us see. 2 into 8 is equal to 16. 2 into minus 4 is equal to minus 8. 2 into minus 3 is equal to minus 6. Minus 4 into 8 is equal to minus 32. 8 into minus 3 is equal to minus 24. Minus 4 into minus 3 is equal to 12. What do you observe? We observe that the new number obtained as a result of multiplication is always an integer. This implies that the given set of integers is closed under multiplication. That is, the product of any 2 integers is always an integer. This property is true for all integers. Commutativity of multiplication. Consider the integers minus 12 and 7. What is the value of minus 12 into 7? Yes, minus 12 into 7 is equal to minus 84. Now, what will you get if you interchange the positions of minus 12 and 7? Will the product remain the same? Let us see. We have 7 into minus 12 is equal to minus 84. Therefore, minus 12 into 7 is equal to 7 into minus 12. Thus, we see that even when we change the positions of the integers, it makes no difference to their product. This property of integers is known as the commutative property. This is true for all integers. Hence, all integers are commutative under multiplication. Associativity for multiplication. Now, consider the integers minus 3, minus 5 and minus 6. Let us find the value of the expression minus 3 into minus 5 into minus 6 and minus 3 into minus 5 into minus 6. We have 15 into minus 6, which is equal to minus 90. Also, minus 3 into 30 is equal to minus 90. Therefore, minus 3 into minus 5 into minus 6 is equal to minus 3 into minus 5 into minus 6. Thus, even when we group the three integers differently, their product remains the same. This property is known as the associative property and it is true for all integers. Hence, all integers are associative under multiplication. Distributive property. Now, let us check whether the integers minus 7, minus 9 and minus 16 are distributive under multiplication. We have minus 7 into minus 25, which is equal to 175. Also, 63 plus 112 is equal to 175. Hence, minus 7 into minus 9 plus minus 16 is equal to minus 7 into minus 9 plus minus 7 into minus 16. This verifies the distributive property of multiplication for integers minus 7, minus 9 and minus 16. In fact, all integers are distributive under multiplication. Multiplication by 0. We know that any whole number when multiplied by 0 gives 0. Let us look examples. For examples, minus 3 into 0 is equal to 0. 0 into plus 4 is equal to 0. Plus 5 into 0 is equal to 0. 0 into minus 6 is equal to 0. This shows that the product of an integer and 0 is 0. A into 0 is equal to 0 into A is equal to 0. Multiplicative identity. We know that 1 is the multiplicative identity for whole numbers. Let us check it as given examples. Thus, we conclude that A into 1 is equal to 1 into A is equal to A. This shows that A is the multiplicative identity for integers also. In general, for any integer A, we have A into 1 is equal to 1 into A is equal to, making multiplication easier. Consider the following example. Find value of minus 25 into 37 into 4. Solution: minus 25 into 37 into 4 is equal to minus 925 into 4 is equal to minus 3700. Or we can do it this way. Minus 25 into 37 into 4 is equal to minus 25 into 4 into 37 is equal to minus 25 into 4 into 37 is equal to minus 100 into 37, which makes it minus 3700. We get minus 3700, which is the easier way. Obviously, the second way is easier because multiplication of minus 25 and 4 gives 100. Which is easier to multiply with 37. Let us solve more examples. Example: find the products of the following. Minus 18 into minus 10 into 9. Minus 20 into minus 2 into minus 5 into 7. Minus 1 into minus 5 into minus 4 into minus 6. Solution: by solving we get 1620 minus 1400 and 120. Example, in a class test containing 15 questions, 4 marks are given for every correct answer and -2 marks are given for every incorrect answer. Gurpreet attempts all questions but only 9 of her answers are correct. What is her total score? One of her friends gets only 5 answers correct. What will be her score? Solution. Marks given for 1 correct answer is equal to 4. So marks given for 9 correct answers would be 4 into 9, which is 36. Marks given for 1 incorrect answer is equal to -2. So marks given for 6 is equal to 15 minus 9 incorrect answers is equal to -2. Into 6 is equal to -12. Therefore, Gurpreet's total score is equal to 36 plus -12 is equal to 24. Marks given for 1 correct answer is equal to 4. So marks given for 5 correct answers is equal to 4 into 5, which is 20. Marks given for 1 incorrect answer is equal to -2. So marks given for 10 is equal to 15 minus 5. Incorrect answers is equal to -2 into 10 is equal to -20. Therefore, her friend's total score is equal to 20 plus -20 is equal to 0. Division of integers. There are some rules that are required to be followed for division of integers. These are as follows. To divide a positive integer by another positive integer or to divide a negative integer by another negative integer, the numbers are divided like whole numbers, without considering the positive or negative signs. And the quotient carries a positive sign. For example, 14 divided by 2 is equal to 7. -21 divided by -7 is equal to 3, etc. To divide a positive integer by a negative integer or to divide a negative integer by a positive integer, the numbers are divided like whole numbers, without considering the positive or negative signs. And the quotient carries a negative sign. Thus, if a and b are 2 positive integers, then a divided by -b is equal to -a divided by b, where b not equal to 0. For example, 20 divided by -4 is equal to -5. -36 divided by 9 is equal to -4, etc. When an integer is divided by another negative integer, the numbers are divided like whole numbers. Find the values of the following expressions. 26 divided by 13, -44 divided by 11, 36 divided by -2, -28 by -4, 23 plus -7, divided by 8, 48 divided by -6 minus plus 2. Solution. 26 divided by 13 is equal to 2. -44 divided by 11 is equal to -4. 36 divided by -2 is equal to -18. -28 by -4 is equal to 7. 23 plus -7 divided by 8 is equal to 16 by 8.